dear students, in our last class we discussed linear polynomials and quadratic polynomials. Let's today clarify your confusion between zero polynomial and zero polynomial. Most of the students are confused with the two terms. So let's clarify in our class today. So look at this. There is a number line and here 0, and towards right you see negative positive integers and towards left negative integers, and 0 is neither positive nor negative integers. For your understanding, we have taken an example -2 and a negative integer. So -2 here is a constant. So can we write -2 in form of a polynomial, that is monomial? Yes. So -2, here the variable x and degree 0. So you know x exponent 0 or degree 0 is equal to 1. So 2 -2 into 1, so -2. So it is called a constant polynomial. But let us consider 0 is an integer and here 0. So 0 is called a constant polynomial, we can say. And let us apply the formula or the conditions of a polynomial. So here 0, variable x and degree 0. So the result is 0 into 1, 0. So when the constant is 0, that polynomial is called 0. But here is a question. What is the degree of a 0 polynomial? The 0 polynomial, you see 0, 0 to power 0, 0 to power 1, 0 to power 2, you go up to infinity. So the degree of a 0 polynomial is not defined. This question was set in the last examination. Come to the second condition. Now you see -2x square. It is a polynomial, it is a monomial. Now you see here a is -2 coefficient of the variable x. So variable x and the degree of x is 2. And if a is equal to 0, let a is equal to 0. So what will the polynomial? What will the result of the polynomial? You see 0 into x square is equal to 0. So this is another way of 0 polynomial. That's why in polynomial there is a condition a is not equal to 0. And if a becomes 0, a means the coefficient is 0, then that term changes or turns into a 0 polynomial. So this is about 0 polynomial we discussed in detail in our last class. But our today's topic, the comparison between 0 polynomial and 0 of a polynomial. So we have taken two examples, linear polynomial and quadratic polynomials. Linear polynomial and quadratic polynomials. We have taken one example here. So some students are confused with px. What is px? Px means a polynomial in variable x. Simply, so let px is equal to 2x plus 4. So 2x plus 4 is a polynomial. What type of polynomial? A linear polynomial. Why? Because the degree of the variable is 1. That we have discussed. So let px is equal to 2x plus 4. And let px is equal to 0. If px is equal to 0, then the polynomial 2x plus 4 is equal to 0. And let us find out the value of x. So 2x here by transposition is minus 4 and x is equal to minus 4 by 2. So we got 2. We got the value of x minus 2. So for that value of x, that polynomial becomes 0. So that value we can write, so px is equal to 0. If we put that value of x here in the polynomial will be 0. The result of the polynomial will be 0. So we write px is 0 at k, x is equal to k. So what is the value of k here? K here minus 2. So k is a real number, any real number, but here k is minus 2. So that k is called 0 of a polynomial. But in this case, k is equal to minus 2 and minus 2 is the 0 of this polynomial 2x plus 4. So never be confused. So k is a real number and which is called a 0 of a polynomial. Let us prove it. Let us apply, let us put the value of k here. So simply we write p minus 2 is equal to 0. Let us prove it. Because pk, simply we write pk is equal to 0. So here k is minus 2. We write p minus 2 is equal to 0. So in place of x, let us put the value of k, that is minus 2. So here you see 2 into minus 2 plus 4. K is equal to minus 2, that we have already told you. So minus p minus 2 is equal to 0. Now you see the result is minus 4 plus 4. This is minus 4, 2 multiplied minus 2, minus 4 and plus 4 0. So simply k is minus 2 and we write pk is equal to 0. Here we can write p within bracket minus 2 is equal to 0. So here k is a 0 of the polynomial, means for the value of k, that polynomial becomes 0. Now come to, this is the standard form of linear polynomial. Now we see ax plus b. So this is the ax plus b. A is the coefficient of variable x and b is the constant. This is the standard form. So from the standard form, we can find out the 0, the value of zeros. Here x is equal to minus b by a by transposition, minus b by a. Here k is equal to minus b by a for all linear polynomials. So how many zeros do we find here? So in case of linear polynomial, only one zero, that is minus b by a. That is called only one zero in case of a linear polynomial. And the graphical representation we have already discussed. It will be a straight line and the line will intersect the x-axis and the x coordinate is the 0 of that polynomial. Hope this part is clear. Come to the next part. Now look at the quadratic polynomials. Quadratic polynomials. So we have taken 3 examples. 5 we shall discuss. 2x square minus 6x minus 8. So this is equal to ax square plus bx plus c. This is the standard form we shall discuss. Let k is equal to minus 1. If we put the value of k minus 1, the polynomial will be 0. So we can write pk is equal to p minus 1. So let us put the value of k here. So means if it will be 0, we can say, so minus 1, the k is a 0 of this polynomial. Now come to 2 into minus 1 whole square minus 6 into minus 1 plus 8. You solve it. Now it is 2 plus 6 and minus 8 and the result is 0. So for k is equal to minus 1, the polynomial becomes 0. So k is a 0 of this polynomial means minus 1 is a 0 of this polynomial. You can write p minus 1 is equal to 0. Come to the second condition. Let k is equal to 0. So we can write pk is equal to 4. Here the value of k is 4. Let us put the value of k in this polynomial. 2x square, 2 4 whole square minus 6 into 4 minus 8. What result do we get here? 2 into 16 minus 24 minus 8. Now 32 minus 32 0. Putting the value of k as 4 or taking the value of k 4 and putting in place of x, we get the polynomial is 0. The polynomial becomes 0. The result of the polynomial is 0. So k is equal to 4. 4 is another 0 of this polynomial. So for this polynomial, we find two zeros, that is k minus 1 and k minus 1, k 4. These are two zeros of this polynomial. So we can write p minus is 0 and p4 is equal to 0 in short form. So come to another example where the polynomial has only one zero. Now you see px, we have taken another example. So this is a polynomial, quadratic polynomial, ax square minus 4x plus 4. So let px is equal to 0. Let px is equal to 0 means the polynomial is equal to 0. And you see, this is the x whole square, 4 to the 2 whole square minus 2 to x into 2. That is a square plus b square minus 2a into b. So this is in form of x minus 2 whole square. This is identity you have already learned. So x minus whole square is equal to implies x minus 2 is equal to x minus whole square is x minus 2 whole square is equal to 0. X minus 2 is equal to 0 implies x is equal to 2. Now you see, we got only one zero of this polynomial. That we can say px or pk is equal to 0 or p2 is equal to 0. So it is here 1 0 of this polynomial. We have written here p2 is 0 because k is equal to 2. Now come to the third situation, third condition, where the quadratic polynomial will have no 0. So we have taken another example, px is equal to x square plus 1. Let px is equal to 0. So as such, which implies x square plus 1, the polynomial is 0. Now by transposition, x square is equal to minus 1, you take over, change the position from LHS to RHS, this is minus 1. So if x square minus 1, x is equal to root of minus 1. Root of minus 1 is an imaginary number that denoted by I is equal to iota. Okay, so here we find no zeros. So we write pk, k is infinity, k is here for this number, pk is equal to I. Here pk is equal to I means imaginary number. Here no zero. So we observed three conditions: polynomials having two zeros, polynomials having 1 0, and polynomials having no zeros. We have already discussed In graphical representation, the hyperbola the parabola may intersect the x-axis at 2 points. So there will be two roots. And if the parabola intersects x-axis at 1 point, that polynomial has only one zero. And that parabola may not intersect the x-axis. Here, the polynomial has no zeros. So this is the basic concept about zero polynomial and zero of a polynomial. But here is a question, good question. The degree of the zero polynomial undefined. For the degree of the constant polynomial, the highest degree of the constant polynomial is always zero. So this question may be said in form of assertion and reasoning. Hope you have understood the comparison between zero polynomial and zero of a polynomial. In our next class, we shall discuss how zeros are related to the coefficients, that is a, b and constant c of a polynomial. So how the zeros are related to the coefficients of polynomials. Stay tuned. If you like, you may subscribe our channel to see our series of academic videos right from class 1 to class 12. Thank you very much.